Hi guys, got another 500 watt ATX power supply here today. This one, I'm told it's not working, doesn't power on, and I've noticed there's a bit of like, it smells a bit baked. This one does. It's like a smell like something's been fried in here. Looking down through the fan, I can't really see any evidence of what that might be. But it just has that PCB looks a little bit brown down this side. Smells like something's cooked. Yeah. So what we'll do is with it, because we don't really know what condition this is in. Yeah. This is a light bulb that I have limiter. So basically with this, you can make one of these. This one's got two light bulbs on. You can make one with just one. Yeah. So this is 100 watt and this is 60 watt. And for now I'll take the 100 watt bulb out, yeah, so we just have a 60 watt bulb here, and the power comes in, it's got you know, like a IEC power connector on here, and power out here, it's an English plug, yeah, so we can plug a power lead in here, yeah, and then we can connect power coming in, okay, to this. Like so power's coming in and going out to the power supply, yeah, and it has a switch here, so when it's set to live, this power is connecting directly to here, so when we switch it on, it just powers, yeah. When it's set to limit, the power coming in here, like shall we say neutral, goes directly through here, and live goes via the light bulb. So obviously the idea of this is, if there's a short or something here, it won't blow the fuse, the light will come on bright, yeah. If nothing happens, it just won't even light up at all. Or if like something like power obviously goes in, but maybe it doesn't start, or at the moment there's no load, yeah. This will like sort of go bright and then go dim. So that's what we have there to test it. I have my headphones tied up in a knot again under the bench. One moment. Yeah, there we go. So yeah, we'll switch the power on, yeah, and we'll have a look to see what happens. What does it do? Okay, it went bright and then it went almost out. Don't smell. Oh, I think I do smell something there. Let's just switch it off. I think I do smell something coming from this power supply. Sorry, we don't have smelly vision on here, so you can't experience that, but it's that kind of like burning lacquer type of smell, yeah. Something getting hot. But let's just check, see if we have any 5 volt standby coming out of this, just out of interest. So we're going to go on 5 volt standby is on the purple wire, yeah. So I'm going to connect the meter to the purple wire, and the other probe on the meter to one of the black wires. It doesn't matter which black wire, yeah. And we'll set this to volts, and I'm going to switch it back on again. If this goes bright and dim again, it means that effectively something here is drawing power. So while we've been talking, it's discharged the main capacitors to some extent, yeah. If it doesn't flash quite as bright, it obviously hasn't totally discharged them. If something's totally discharged them, something is drawing, you know, power basically. Let's see what it does now. Yeah, it didn't flash quite as bright there. Right, we have 2.5 volts on 5 volt standby. So this has obviously got some sort of problem, yeah. I mean, I can switch it directly to live. I know it won't go bang, but we've still got 2.7 volts there, and this has a strange smell. Okay, so that's the symptoms. Now let's see if we can find out what the problem is with this. So I'll just disconnect this for now. Make a bit of space on the bench here. I'll put my other light bulb back in before it breaks. These things are getting harder to find these days. I'm sure you know, you can still buy them. I've seen them in the shops, but some of the bigger shops, you don't seem to have them anymore. And you can't use an LED or fluorescent for this. You need a proper, yeah. You need a proper. Can we do it that way? You need a proper light bulb to do this. And some idiot seems to have stopped making them somewhere. And they're like essential, yeah. Okay, so let's put that out of the way. We don't need that for now. Let's zoom in a little bit and let's have a look see what's actually going on inside here. I'm guessing from the smell there's going to be something visibly obvious going on inside here. Okay, let's zoom the camera down. So there we have it. I'm going to buy myself one of these desk microphones. I might do that this weekend as well. It's getting annoying now. This is really the only microphone I have on this headset. Let's go high tech on this channel. Let's get like a proper desk microphone, I think. Okay, let's open this up and see what we have. Oops, screws have bounced off. At least one thing with ATX Power Supply is generally speaking easy to get into. Yeah, they're not difficult to open them up. Okay. He says, oh, has some sort of warranty seal on it, some paper seal here, yeah. Okay. That smell still in here. It's not strong. It's not a strong smell. Let's see if we can disconnect the fan, yeah. Obviously, there's no point me trying to start this power supply because I only have like less than 3 volts on the 5 volt standby, so it's not going to work anyway. Where's my little one of these tools to do this? Let's see. Yeah. So I need to kind of like free the adhesive. There's always a bit of glue on these things, yeah. To get the thing and hold the bottom bit down while I pull the top bit up. Otherwise, what tends to happen is the whole plastic thing comes off the board altogether. I don't see anything burnt. Oh, this looks a bit baked here though. Something here looks a bit like it's been cooking, yeah. There's some dust in, but it's not a huge amount. I'll just let me clean the dust out of this as well. Okay, that's got clean at least. Well, there's a few things I noticed about this straight away. First of all, it has a switch on the back, 220 volts, 220 volts, 110 volts, which is not common. I mean, these days, normally a power supply it just works from like 80 to 240 volts or something like that, yeah, automatically, and that seems a bit like cheap, yeah, a little bit cheap. I'm not sure exactly what you're switching. There's just 2 wires. It obviously goes down between these capacitors. That's the first thing I noticed. Second thing I noticed, yeah, it looks a bit like it's been warm here. That's possibly where we could smell. Third thing I noticed is that down by the main capacitors here, all this kind of like gooey stuff, yeah. This could be glue that's dried out, but it could be something that's come out of these capacitors. And this one looks like it's bulged a bit. Can we see? This one looks like it's bulged a little bit on top. I'm thinking that these capacitors we definitely need to check if they're actually any good, yeah. I also notice another capacitor here that the top is bulged, and it has, and another one here that has that kind of hollow sound. You see, a capacitor normally, if you tap it, this one sounds a bit hollow. It's a bit like, you know, tapping on the wall, yeah. So I'd certainly be looking at these capacitors. And the last thing that strikes me with this is I'd be very surprised if this thing can actually deliver 500 watts. It's rated power. I mean, it's a 500 watt PSU, but it's almost like nothing in it. I mean, even the wires are thin. I don't know. I think it's El Cheapo, this one, yeah. But anyway, we have it to repair, yeah. It's a similar design to the previous ones we've looked at. So we have 3 transformers, yeah. Even the transformers look small in this compared to the other ones. So the big transformer is driving. Let me just set the focus on it. Okay, I've just focused it and you can see a little bit better in here now. So we've got 4 diodes, bridge rectifier coming into these big capacitors, yeah. This small transformer, this one, will be the 5V standby. So this diode here is on the secondary side, and this capacitor is probably the smoothing for that, yeah. And the purple wire kind of comes down here, so we can track it, but I'm pretty sure we can say the purple wire goes to here. I can just check that now, to be honest. Let's switch to resistance mode. Let's get into the purple wire on the connector, yeah. So we'll get into the purple wire. There we go. So that will come to this diode, I would think. Yeah. So this transformer drives the 5V standby, and the 5V standby will also power this circuitry down here. And I can see 2 chips. I haven't looked at the part number yet, but at least one of these will be driving the main switching transistors which are on here, yeah. I can see 3 transistors here, 2 big ones and a small one. The small one is probably driving this transformer, the 5V standby. The 2 big ones will be driving this transformer, which gives 3V, 5V, 12V, yeah. So other side of the transformer, these are the rectifiers. There's 3 diodes down here we can see. There's none on the other side, so there'll be 1 for 3, 1 for 5 and 1 for 12. That's your rectifiers for each channel. All these capacitors over here will be on the 3, 5 and 12V rail. There's 2 chips down here. I'll have to just go and look up to see what they are, but basically this transformer will have to be driven by an oscillator. I can see down here a transistor, yeah, and a capacitor. So it could well be that there's a little circuit here around this transistor, maybe involving the opto-isolator, which is also a photo transistor on this side. So around the opto-isolator on this is probably an oscillator that drives this transistor, that drives this coil, like how the 5V standby gets. Why there's 2 chips here, I'm not sure. It's possible one's driving the 5V standby, but I very much doubt that because they're both on the low voltage side, and I don't see how this would then drive that, yeah, that the primary of this. We can have a look. So that's, I think, roughly how this thing is put together, yeah. We can have a look out of interest. I think this is faulty capacitors, at least to start off with. But we can have a quick look and just see what these 2 chips are and see if we can get some idea of how this actually works, yeah. So this one, it's an LM something or other. Can you see it? LM339LD. That's that one. Let's just make a note of that. Okay, I just got a bit of paper and just made a note of that one, yeah. What's the other chip down here? Oh, that's not good. The other chip apparently seems to have a little hole in it. Can you see it? About halfway along the chip. Here. There, can you see that? There appears to be a hole in it. What's this thing? It's a KA something. Because of the hole, I can't read it. Let's see if we can see that under the microscope. Okay, I've got the microscope. You can clearly see now, yeah, that there's something gone wrong here. There's like a hole in the chip there. Yeah, by that, it's a number 2. I can read the part number. So you can see the damage. No, it's a number 7. It looks like it's a KA 7500BD, and you can see where it's blown or something's happened to it. The fact this is near to these components that where the board's a little bit burnt, yeah, and it's also something smelling of getting off. So I think we can pretty much say this is what the problem is there. So it's a KA7500BD. Let's make a note of that one. KA7500BD. Yeah, I think it's a 7. This is where the chip's damaged, but let me actually look down the microscope. It might give me a... Yeah. Yeah, I'd have to say that's a number 7. It's hard sometimes. I'm difficult getting the focus for you guys and the focus for me at the same time. Okay. So just from a visual examination of this, I think we can determine. I stuck on the back end of the microscope double boom stand. Yeah. So it was a good place to put the camera. Yeah, so this is looking just with visual aspect that we have suspect capacitors, unless this is just dry glue. We have definitely one faulty capacitor here for sure, possibly others, and that we have a chip which is kind of got a hole burnt in it, and some components nearby which is what's burning. But I think that explains the burning smell. So let's have a look online and see if we can figure out what these two chips are. Yeah, what are these two chips that we have here? Okay, let's have a look on the internet. By the way, I'm surprised. I am surprised. Nobody has asked me yet where this photograph is. This wallpaper I have. I took this photograph myself. Can anybody tell me where that is and what that is? Yeah, what we're seeing here. I'd say letters on the postcard, but just stick them in the comments below. Yeah, it's easier and quicker these days. They still have They still have postcards. I've seen them in the shops here. That's something else that surprises me. Okay, let's see what these chips are. So we have an LM339LD. That's the one. Well, let's see if we find all data sheets as well. Normal use. No, it's not another. That was a quad voltage comparator. That's what this is telling us. What does that do? Let's have a look. Quad voltage comparator. Well, that quad voltage comparator, that there compares them voltages. That does, look it. Yeah, that there compares them voltages. This must be something to do with the regulation circuit that's monitoring the 3.3, the 5 and the 12, and then I suspect it's driving it's not, yeah, it's probably talking to the chip next to it that actually drives the main transformer. That's what I think that there does. Quad voltage comparator. Okay, nothing much else to say about it. That's what it is. Okay, so I think we can say that's in the feedback circuit somewhere. Yeah, somewhere in the feedback circuit. Okay, what's the other one do? Now I'm assuming the other one must be driving. It must be the pulse width modulator, the one with a hole in it. Yeah, KA7500BD. Okay, Fairchild. Another Fairchild. A lot of Fairchild chips and power supplies I find. It's like they kind of own that, you know, area of business. Yeah, switch mode power supply controller. So, pulse width modulator regulator. Yeah. So this is what's driving the transformer, the main transformer via the two transistors. Yeah. A used control circuit for pulse width modulator, switching regulator, 5 volt reference voltage circuit, 2 overhead amplifiers, a flippity flop, output control. It controls the transistor control. Yeah, they control the main transformer. Okay, so we know what they are. we know what we've got. Right, so this is what we have, guys. This is what we have. I just need to zoom out a little bit to show you this. We've got AC coming in, yeah. There's no power factor correction circuit in this, no big inductor, no nothing. It's obviously cheap and was probably made either before that sort of circuit was necessary in items sold in the EU, or they couldn't be asked because he wanted to make it as cheap as possible and nobody would notice. So we have AC coming in directly to the bridge rectifier, the 4 diodes here, yeah, but we'll just draw it as a bridge rectifier. AC, AC, plus, minus, yeah, coming out. So that's what we got. Okay. Across the plus and minus, we've got 2 big capacitors, yeah. Like so. I won't bother with how it switches between 110 and 240. I'll have to have a look to see how it does it. Now, so we have that, yeah. That's these 2 big capacitors of these, yeah. On this heatsink, we got 3 transistors, yeah. By the looks of it, they look like the transistors, most likely. So we have 3 transistors. Where can I draw these? 2 of them. I'll just draw them as blocks. Yeah, I won't bother because I don't know. I haven't seen how they connected up. But these are transistors. Yeah, Q1, Q2. We'll call them. Yeah, these are transistors, and they'll be connected to the main power top of here. Yeah. Well, no, they won't. They won't be connected like that. We'll have a transformer coil. Yeah. This is your main transformer, and somewhere around this transformer there'll be 2 transistors connected somehow to it, yeah. And then the other end of these transistors will go to what I call hot ground. That's the negative end of this bridge rectifier, yeah. That's not like earth, because half the time it's connecting to that AC wire and half the time it's connecting to that AC wire, so it's kind of like floating, it's switching at 50 times, 60 times a second between live and neutral, yeah. So that's how these are. We'll call them Q1, Q2, that's your transistors, yeah. Also coming from here, possibly via a resistor, will be a connection to the other transformer. It may or may not have a resistor, probably doesn't. And here we'll have another transistor. That's the small one there, yeah. And that will also go chassis. It's not chassis, sorry, hot ground, yeah. This transistor will be connected to some sort of oscillator, yeah. I think there's 2 L's an oscillator circuit, yeah. That'll connect into some sort of oscillator circuit, which is going to be in this area, yeah. This transformer, this is now ground. This is isolated, yeah. That isolated. This is ground, yeah. This transformer will go to 5-volt standby, yeah. And it'll also power this voltage comparator in this pulse width modulator controller. The comparator will be connected into this output here and monitoring the voltage on the various rails, yeah, and it'll be sending a signal to this, I would say, to basically alter the amount of time these big transistors switched on and off. Sorry, these big transistors that are driving this. So this will go, let's draw it, to the KA 7500, yeah. That'll power that. That'll ground, yeah. Coming into this will be the LM339, yeah. And that will be monitoring the voltage rails. So here you'll have 3 secondaries, 3 sets of diodes, yeah. Probably double diodes, yeah. Each of these will go to ground. And then coming out of here you'll have 12 volts, 5 volts, 3.3 volts, yeah. And this LM339 via some resistors will monitor these, yeah, I would say. This is all supposition and guesswork, but I'd say that's connecting like that, yeah. This set will be powered from the 5-volt standby, and again this will go to ground. So that's sort of how that'll wire work, yeah. Right. There's 3 transformers, isn't there? Right, the other transformer is here. Right. this end of the transformer, so on here, this is the primary and these are the secondaries, yeah? This is the primary. This is the primary and these are the secondaries. On this one, this side's the primary and this side is the secondary. And this primary will be driven one way or another from this KA, yeah? And the secondaries, one way or another, will go to the base of these transistors, or the gate that drives them, yeah? That switches them on and off. So in here, effectively, are transistors. I'm sure there'll be like a center tap or something in this primary here, unless these are just in parallel. Okay, so that's basically how it works. So it's isolated there, and then the last thing, there'll be in here an opto isolator. So the opto isolator is here. Yeah, this side's an LED. Yeah, to ground to a resistor, and this LED shines onto a photo transistor in this side. Yeah, hot ground. And this will go back into this oscillator circuit. Yeah, and this, via some sort of resistor network, will monitor the 5-volt standby. Now we have it, that's what we've got. So, power comes in, charges the big capacitors, yeah? Puts power to these big transistors through the primary of this, but nothing's switching at the moment, yeah? This oscillator circuit will be powered via resistor from here. So this will have like about, say, 250, 300 volts on it, yeah, something like that. So this powers up, it starts this oscillator going, yeah. I mean, there'll be more, there'll be, you know, capacitors in here and things to make the circuit up, Zener diodes, but this oscillator powers up and starts driving this transformer, yeah, and generates a 5-volt standby. The feedback via the opto isolator feeds back to this oscillator, so that's how it knows when it's got a 5-volt standby, and that's how it regulates a 5-volt standby, yeah. 5-volt standby powers up this KA 7500. This drives this transformer, primary, from the secondary starts to switch these transistors. So these are now switching on and off, being driven by that, and they're pulling power through here and charging up the transformer, yeah. And now we're getting voltage out of the secondaries, 12, 5 and 3, yeah. That powers up. Your ATX is now on, and this LM339 monitors these voltages and controls or feeds the signal back to this KA7500, which that's how it regulates the output voltages, and that's how this works. I mean, there's a bit more in it. There's obviously a circuit so that when you press the on, you know, you have your on button on the motherboard, yeah, the green wire on your ATX, yeah. So the green wire, which is power supply on, this is controlled from the motherboard, yeah. One end of that goes to ground and the other end of the green wire goes to here. So when you press your power supply on, that's what starts this. Yeah, it doesn't just automatically start with 5-volt standby. That's the power supply, guys. That's what we've got. What's wrong with it? These look suspect. Yeah. This has got a hole in it. Yeah. On here, from the 5-volt standby, there will be a capacitor to ground, yeah. This one, and that's gone. That's gone. So I think we've got like a chicken and egg situation here. Capacitor probably dried up and failed, which probably has messed the voltage up on here, which possibly blew that chip. Yeah. These these capacitors may have failed. I'm not sure they have though, because you know when I first switched on, I got bright on the light bulb, it went dim, and that bright into dim is charging capacitors. So it may be that this stuff down here is just glue, yeah, or maybe they're working but not working very well. So we need to look at them. But maybe if they've lost capacitance, there's too much ripple in the circuit. And that's what blown this. If you want me to put money on it, failure of the capacitor here on the 5-volt standby caused too much voltage into here and blew it. These transistors that drive the main transformer, they're not short. If they were short, then the light bulb would come on bright. Yeah, so we know they're not short. And these components, where it looks like it's been cooking, they're around this chip that's got a hole in it. So, what we're going to do, I'll take the circuit board out. We'll remove these capacitors, make sure there's no charge, and then we'll test them. Yeah, I'll remove that capacitor, which is this one, and see if that's any good. I'll see if I've got a chip, but I probably don't have a chip, so I'll probably have to order one. And I'll have a look at these capacitors on the output, see if they're any good or not. I think with this one, a few capacitors and the chip will probably have it working. Okay, guys, let's take it apart. Okay, so I've opened it up. First thing then, and I was careful when I opened it up not to put my fingers anywhere in this area. This is the high voltage side of the circuit, yeah. And before we do anything else, we need to check if there's any charge in these big capacitors, yeah. So I've got the meter on volts, and I'm just going to check directly across the capacitors. Okay, that one's discharged, there's nothing there, yeah. And here's the other one. 1.2 volts, 0.012 volts. So yeah, 0.005. The fact we got a reading means I was definitely making a contact, because you know you want to make sure you made a contact, not read zero and did that and got 300 volts zap or something. Which you wouldn't, would you, by the way, because you'd only get 150 volts because there's half in each capacitor. But it's still going to hurt, yeah. It's still going to hurt. What else have I spotted? Board's a little bit distressed around here, which seems to be around a power resistor here, which is obviously getting warm. So let's take these two big capacitors out first. Let's just make a note. Are they marked? Yeah. So we can see on the board, you can probably see there's like stripes here, yeah, on the negative, and stripes marked there on the negative, yeah. So we know which way round it go. Are they any good? Is that stuff just burnt, well, dried up old glue, or it's actually come out of the capacitors? Well, one way to find that out. I could probably actually, I've just let the soldering iron warm up. I could probably check them in circuit, because they're in series with each other, yeah? Because they're actually in series with each other. Effectively, there's no connection to anything else. Let's just see if we can actually get an idea of them in circuit. Put the ESR meter on. I'm on the one. It's on auto. I'm on auto range. It'll do. Let's have a look. Check the ESR of these. Yeah, 0.12. These look like they're good. Yeah. What's this one? That one's considerably higher than the other one, yeah? No, 0.19. No, they're similar. They're probably okay, they're probably okay. But where's the capacitance meter? Let me get the capacitance meters. See what that reads. See if it reads anything like the rated value. So these things are 330 microfarads, 200 volt, yeah, 330. So let's put it on to 2000 range. Negatives this end. So this capacitance meter. 220. I mean, these things are never very close to tolerance, but I'd probably expect them to read a bit higher than they really are. I'm going to take them out. They don't look bad, by the way. They don't look bad. But I'm going to take them out and have a look at them and see what we think of them. So once I get them out, I should be able to see if that's glue that's on the board, which I'm suspecting now it probably is. Just added some leaded solder to make it easier. Get a bit of flux also to make it easier. Got solder braid. Let's see if we can get these out. Yeah, it's coming. Just find my cutters and just take the bit off that. Where am I? Found some cutters, found the old ones. Okay. It's off. Okay. These should come out now with just a little bit of persuasion. No, that's out. Let's have the other one out. Yeah, they're out. Okay. How did they look? This one seems to have like 2 holes in it, which one doesn't have. Yeah, they're the same. Dong Bowie capacitors, yeah, Dong Bauer capacitors, bit of Dong Bow. I don't like them. I don't understand why this one has these 2 holes and this one doesn't have. Is that? No, it's not come out the bottom of the capacitor as such. It looks like it was glue. So let's check them now. ESR. The ESR is really low. .09. That's one with the holes in it, effectively. 0.04. Yeah, this one's reading a bit higher than this one. I don't like them. I suspect they probably are working to some extent. Also, where's my capacitance meter again? See what this makes of it. Yeah, 212, and it should be 330. Is that one going to be lower than this one? Yeah, 230 odd. If they ain't gone, I think they're on the way out. Let me have a look, see if I've got anything in my stash of bits that we can put in there. Yeah, okay, I found a couple of these. They're salvaged. 470 microfarad, 200 volts. They look like better capacitors. I'm not sure if these will fit. They might fit. I mean, there's room in here if I can get them to physically fit. It looks like they might. I think I'll have a bit of trouble just get it under the edge of the heatsink here. But once it goes into the board, it will go down a little bit. If I can physically fit them, I think I probably could. I'm sure they'll be better than the original ones. The fact they're higher capacitors probably wouldn't harm it any. Just get slightly more surge current when you switch on. So let's have a look. Let's see what the ESR meter makes of these. 0.0270. It's about 0.03. That's low. Yeah. This one. Of course, the ESR isn't quite so important on like capacitors on like working like on main frequency. It's high frequency ones more, but yeah, those both look good. Yeah, they look better. Let's have a look what the capacitance meter thinks. I mean, normally with a capacitor, you'd expect it to read more higher than its rated value. I mean, they're not very close tolerance these, especially electrolytics like these. Yeah, 485, and that should be a 470. That's a good capacitor, I think. What's this one? Yeah, 492. Yeah, I'd say they're good capacitors. Let's see if we can actually get them to fit in the board. I probably could, but I might actually have to take this heatsink off to do it. Which actually wouldn't be difficult because I can just undo the 3 screws in here. Yeah. Undo the 3 screws in these transistors and just screw back into it. Unsoldered, there's like a couple little pillars which hold it on place, yeah. So I could actually, without unsoldering the transistors, just take the screws out and take this off. But let's just have a look, see if we can actually get this to physically fit. I push this resistor back a little bit, making sure this doesn't touch the heatsink, because the heatsink's insulated from these. There's little rubber pads, but it looks like where it goes to the board it's not connecting to anything either, so if that does touch that, it's not going to cause a problem. But let's try not to. So we get this to actually, yeah, a little bit of fiddling and it went, yeah, nicely. Can we do the same with the other one? Negative to where these stripes are, yeah. So I kind of like weaved it into place. I need to get this red wire out of the way. There we go. See if we get us to go in here. I'm sure these capacitors are far better than the other ones, even when the other ones were new. Let's try. See if we can get us to go in. It's in the right position. This is whether I can get the pins. Yeah, I think I'm gonna have to just kind of clean the ends of this. That's the old solder off them. Yeah. Let's. We don't need this anymore. We take a photo of it and stick it on your wall. Yeah. How the power supply works. I'm just cleaning the bit, that little ridge of solder on the pin. Yeah. It was kind of stopping it from going into the hole. See if that'll do it. Otherwise, I could actually drill these holes out a little bit. It's not a problem, you know. I can make the hole a little bit bigger if I need to. Sometimes, you know, bigger hole a bit easier to get into, isn't it? You know. Or we can just do this until we get into the holes that are there. Yeah, I think I've got it. I have. Yeah, I've got it. So they've come through. Yeah, they've come through the board. Okay, so we can get away with these. Let's solder these in. There we go. Not soldered very well. I think I want a little bit of flux on it, yeah, which isn't exactly soldered in very well. A little bit of flux on this one in particular. And if I push on the capacitor at the same time, that was the one falling out, by the way. That one's in flush now. That one's gone in nicely, so it's holding it all in place. The other one's now further in than it was before, so I can now get this soldered. Yeah, that's nicely done. The other one fell out, but it was easier to get in the first place. So there we go. So once again, try and get one pin soldered first and push this into place. Yeah, let's hold it while that solidifies. That's nicely in. And this one. Okay. So that's dealt with that problem. Let's take this capacitor out. This is the one that's on the 5V standby. I'm sure it's on 5V standby. Yeah, it's here. There's some diodes around here as well. Pretty convinced this is on 5V standby. Where is it? There, is it? Yeah, looks like it's here. Okay, let's see if we just get this one out without using any extra solder. Just pull it out. sorry guys, let me just get in a position where you can see. Yeah, so I've got hold of the capacitor basically. I'm just going to warm the pads and just see if it'll just pull out. Yeah, just leave it slightly to one side, slightly to the other side. Yeah, it's coming. It's out. Yeah, it's out. It went that way round, and it is marked. Yeah, so the negative end of the capacitor, again on the board, has like a kind of little stripy mark down there. Yeah, I just knocked somebody on the floor, plunger at the syringe. Yeah, so yeah, let's get this out of the way. So it's marked there, yeah, on the board. You can see the negative end. Okay, so that's out nicely. Let's just clean the holes. We'll test this capacitor. Let's see if I've got something suitable that we can replace that with. Okay. There's the two holes where it came from. Might need a bit of flux, but let's just try. Yeah, it's usually, once you've got the thing out, it's normally quite easy with the braid to actually clear the holes. Yeah. So this is it. 1000 microfarad, 10 volts. You can hopefully clearly see the top of it is like domed. Yeah, it's bulged outwards, which tells me that's failed. Capacitance meter. So it should read 1000. So I almost lost my dong bow capacitor there. The dong bow. I almost lost them. Okay, let's have a look what this has got. Wow, it's reading like 79 and it should be 1000. Yeah. So we know that's no good. Let's have a look on the ESR meter. See what this thinks of it. Strangely enough, the ESR. Oh no, I think I've shorted the leads together. Yeah, look at that. 8 ohms. 8 ohms, 8.5 ohms of ESR. That's crazy, man. Crazy, man. Okay, so have we got a suitable capacitor put in here? It's 1000 microfarad, 10 volts. Let's have a look at my stash of bits again. Okay, yeah, I've got this one salvaged again, 1000 microfarad, 16 volts. So that's not a problem. We can use a higher voltage rating one. I'm sure I can physically get it to fit. But this one's like says 85 centigrade on it, yeah, maximum working temperature, and I'd probably tend to try and put something that's 105. What's the original one? 105 centigrade it says on it. So I've got another one here. This one's 1000 microfarad, 10 volt. This one's marked 105. Yeah. Sam Young, 105. Let's see if it's got a low ESR. I'll be happy to use it if it's got the right capacitance. Of course. Let's see what this says. Well, capacitance is 1000, just over. So normally a capacitor reads just a little bit higher than it is rated. Only sometimes you read a little bit lower. Let's have a look at the ESR of this one. I want something low, like 0.03 or something. The connection. Something a little bit lower than that. Another mooch around in my stash of bits. Yeah. What's this one? 105 degree. What's this one read? Yeah, 0.0. It's okay. 0.07. What was that one? A little bit higher. Yeah, let's use that other one. That seems to read okay. Yeah. Okay. So let's see if this will physically fit in. So again, it's got quite short leads because it's been salvaged from something or other. Let's try and straighten the leads up, clear the bits of solder off them, and then see. I mean, most of these salvage bits have probably been taken off power supplies, so they're probably quite suitable for use on power supplies. And that's probably where most of them came from. Okay. Let's see. There we go. I mean, sure, I could buy some capacitors, but this thing is hardly worth it. Yeah, it's not really worth spending any money on. It's like, you know, obviously a very cheap power supply. I'm fixing this more for the experience, yeah, and for the educational value. It's not really worth anything itself. That's that one in. I can probably just, yeah, push the one in now, so the other one's coming through the hole nicely. That's the other one. So that's the visibly questionable capacitors change. Yeah, all these on this thing. I should have desoldered these wires. One of them fell off anyway. I have to stick it back on the switch. These visibly look alright. I mean, I'm not saying they are, but they don't look bad. What I think I'll do with this now is let's remove this chip, yeah, because that's obviously got a hole in it. And then let's try and power it up. I want to see if the 5-volt standby comes up at 5 volts. If it does, then we'll have if it's worth us getting one of these chips to repair it. Yeah. So this is the chip I want to change. We could do this with the desolder braid, but I'm going to do it with the vacuum desolder. It's just easier. Okay, so the vacuum desoldering tool's up to temperature now. Both these red wires have fell off now. They only go to the voltage selection switch. I can soon solder them back on. So which chip is it? It's this one. So let's get a bit of leaded solder on it first to make it easier to unsolder. So I'm just going to go across each of the pins. Can we get the focus a little bit better on that? Yeah, that looks a bit better. So let's go across all the pins on here, adding a bit of leaded solder. Right, if you don't have a vacuum desoldering tool, the easiest way to remove this without damaging the board, yeah, is to cut all the pins off the chip, because we're not going to use it again. It's got a hole in it. Yeah, it's not like something we need to keep or anything like that. So the fact I've got a solder bridge there isn't going to bother me at all for now. So what you can do is you can come down this side, yeah, with a pair of cutters. If I just find out where my cutters are, should have put them back where they belong, and I didn't. So easy way to do this if you don't have the desoldering equipment is to come down here and literally cut every leg off. Yeah. In fact, let's do it this way. Let's do it this way. Let me show you. So we cut all the pins off the chip. Yeah. Let's do it the ghetto. Let's do it the ghetto way. You know I've got one of these, but let's do it the ghetto way. Yeah. So we cut all the pins off, yeah, and we've actually removed the body of the chip now, yeah. The thing that's got obviously burned out. So what we can do is now is we can actually kind of like push these pins through the hole, or we can use a pair of tweezers and pull them through the hole. So if we get some solder braid now, they should all fall out basically. If they're not falling out, like they're not falling out, we need a pair of tweezers, yeah? Or long nose pliers or tweezers, we'll use tweezers, yeah? And what we do is, we get hold of the leg of the thing itself, yeah? And we get hold of the leg and we literally just heat it up from the other side and pull it out. Let me show you this. So I've got hold of the leg. I'm just going to warm it up, see, and out it came. It's out. And so on. So we just warm up. They're just coming out now, yeah? They're just coming out the board one after another. I'm now going to do it the easiest way because I was showing you, but yeah, if you haven't got the equipment, do that, yeah. Okay, I'll do it the easy way, but you can see this is perfectly doable job. Look, yeah. It's probably best as well when you're doing this. 1, 2, 3, 4, the 16, yeah. 1, 2, 3, 4, 5, 6, 7. Because you don't, what you don't want are some of these pins, yeah, falling down into the circuit somewhere, yeah. So you know, when I get the tweezers, I wasn't quite sure where some of them were going. So it's best if we can account for every single pin, yeah. You can see how easy, you can't you, I'm off the camera. Yeah, you can see how easy these are coming out now, so I'm just literally taking them at the board, yeah. There you go. There's one that's still a little bit stuck. Yeah, it's just coming. It's out, yeah. So all the pins are out now. Yeah, so as I was saying, it's probably best just to see if we can actually account for every single pin. Then we know for certain we haven't got one that's fell down in there and got between two components. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 of them, yeah. 9, 10, 11, 12, 13, 14. So there's 2 missing somewhere, yeah. They're not on my bench. 15. There's still one missing, and it may have just found the floor, but I need to have a good look now to make sure that that isn't somewhere in here, yeah. The fact I can't account for one of them isn't good. I mean, it might have flirted off somewhere when I used the tweezers. But let's just make sure we can't see that anywhere in here. No, I can't. I'm having a good look. Yeah, I mean, don't spend forever, you know, but the fact that you couldn't find one, it was definitely worth having a look to see. Okay. So that's that, yeah. Right. I've also noticed, by the way, that on the board here it has another part number, TL494. TL494. That's probably a compatible of the one that was in. If I can't find the one that was in, or they're expensive. Yeah. Okay, so what we need to do now is stick these 2 wires back on where they've come off the switch. So I'll just do that. Okay, so I've soldered the 2 red wires back onto the voltage selection switch. I'm guessing that just shorts out one of these big 2 capacitors, so you've just got one capacitor when you're on 110 volts, because they're rated at like 200 each. I'm guessing that's basically what that does. It just effectively connects, you know, like one of these directly, so it's just got one. I haven't looked, but wouldn't be surprised. Or maybe I've got it completely wrong. I'm not a circuit designer. Well, I do a fair job of guessing what things should be doing, yeah. Guessing how they work, or should work. Okay, so these components down here that look a little bit fried. It looks like we've got a 1.5k resistor. I think it's brown, green, red, but hard to tell because it's cooked. But yeah, it looks like it's probably is brown, green, red. And then the other two look like the what have we got? I see red, black, red. 2k, that's a bit of a strange value. And we've got a couple of diodes, yeah. So, seeing as this area is a little bit cooked, it could just be because of this chip which had a hole in it. It's obviously blown. But let's just have a quick look at this area as well, because we can see something's been getting pretty warm down here. We can check the resistors if they look sort of okay. 2.6k. Oh, I bet it's red, purple, red. That makes sense. And the purple looks like it's black. 2.6k. This one I think is a 1.5. Yeah, 1.5k. Then we've got two diodes, yeah. So just go to diode mode. We should get, yeah, that's the diode junction and nothing the other way. Yeah. And again, diode junction, yeah. Nothing the other way. Okay, so that area, although it's a little bit cooked, it doesn't look like there's anything faulty there. Okay, so what we'll do is now then we'll power this up, yeah. So let's power it up and see if I have 5V standby, because irrelevant of whether this is in circuit, this powers all the main voltage outputs, yeah. But irrelevant, where are we? Yeah, there you go. So we've removed this because it was blown, yeah. So obviously there's no drive now to the main switching transistor, so all the outputs can't work. But irrelevant of that, this oscillator should still power up and there should still be 5V standby. And now I've replaced this capacitor and removed this, which was probably, you know, obviously it was getting hot, so it was putting quite a load of voltage on this 5V standby. I'm hoping I've got a good 5V standby now. Obviously the thing can't start up. The fact I had 2 point something volt here tells me this oscillator is actually working. It's just either the capacitor was basically fooling the feedback, so it thought it had 5V when it didn't, it was only 2.7, or there was a high load by this thing getting hot, which it was, which was dragging that down, so it couldn't generate 5. Okay, so that's that. So I like to just balance. Let's put it onto the piece of paper. Make sure there's no pins. I've got rid of all them pins I took out the board. Put it on the paper. I mean, this mat isn't conductive, but when I've got high voltage, I'd rather just put something on there as well insulated. Yeah, a piece of cord or something like that. Get these things out of the way. We can measure the 5V standby by putting the meter somewhere where you can see it. Yeah. 5V, and again we can go from the purple wire on the ATX connector, that's 5V standby, to any of the black, because the black is ground, yeah, there's loads of black here. 5V standby to ground, so we're monitoring that. Sorry, it's warm. Upper lip's sweating. We still have the Kalima, I mentioned it yesterday, so the temperature's like, you know, well up again. What's the ambient temperature in my workshop today? Yeah. Oh, it's not so bad. It's 25°C with the air conditioning on. Yeah. With the air conditioning on, it's what, 8:15. It's been on for like 3 hours. The aircon. Okay. We're ready to go. Oh, we're not ready to go. We need power leads, don't we? We need some power leads. So let's take the light bulb again. I'll take the 100W one back out again, so I'll just have the 60W light bulb, so switch it to limit, so the worst thing that could happen is the light bulb will light up. Nothing can actually go bang. With the 60W light bulb in circuit, this should flash and go dim, and this should then generate 5V because there's almost no wattage coming out, so that shouldn't really affect it. I've noticed with PFC circuits these flash, and this thing's got no PFC because it was made by bloody Noddy for tuppence, yeah. So that's not going to happen. So power coming in, we'll switch power into the actual thing. Yeah, the power's off at the minute. I've got it all switched off while I'm doing this. Put that in there. You see the two red wires I've soldered back to the switch, which is still set to 220 volts. So we check that. So this is like bloody Apollo mission, isn't it? This, you know, check, check, check. We're all ready to go. Let's switch the power on and see what happens. Yeah, okay, so you flashed it off, and we have 5 volt standby. Do I smell the sweet scent of success? Yes. Okay, so what's left to do with this? Can we get the bits? Is it worth getting the bits? Yeah, it's got to be worth getting the bits. That's, yeah, it's just yours now. KA7500. How much? Sorry, KA7500. Hey, what's Ali think? What does Ali think? And have I got one? That's another question. I don't think I will. We can have a look. KA7500. Well, well, I can get 10 of them for 76 cents. How much is the postage? Oh, so no, he's getting back 10 of them for 61 cents. How much is your postage? I should see it with the shop. I obviously clicked on the wrong place. Oh, 88 cents. Oh, what a rip off, eh? So I can get 10 of them for like 88, 140, 149. Is my maths good? 88, 98, 108, 140, yeah, 149. That's a 7500 big. I'm not sure what mine said on it, but I'm not sure if there's even a difference. I can check. Yeah, these ain't expensive. How much is this one? B seems to be all of them anyway. $0.78 with 80. Yeah, B. Yeah. Okay. So in this occasion, I think it is worth buying the bits, just because, like, you know, they're free. Really, there isn't even, damn it, they're free. And you know, 61 plus 58 is just getting cheaper. 60, 100. That's like 121. 1 €1.19. Let's put a wish on that. Yeah, let's have them. I'll have to log in to do it. They're not going to turn up till July the 2nd, but that's 3 weeks. We can live with that. Yeah, so Ali says yes. And I can get 10 of them. Think of all the stuff. Think of all the shit I can fix with that. All these supposedly 500 watt power supplies I can fix with that, eh? Look at that, guys. Okay, so it's Friday. Car booty at the weekend with a bit of luck. Try and find some more stuff to fix. I will say the car boot sale is getting quiet now. As we get into the summer, the car boot gets quieter, less traders, less people. So like in the winter is when the car boot sales are busiest. So it's getting harder to find stuff, but you know, we can have a look and see what's around. Okay, guys, so have a good weekend. Buen fin de semana, and I'll see you all next week. Cheers now.